Okay, so we're on to the first part of alcohols. Alcohols is quite a big section, so it's going to be a long enough video. Let's run through it as best we can. So alcohols are figured out by an OH group at the end of a molecule. And again, that OH group is an oxygen bonded to a hydrogen, but often we write it as just OH. And then alcohols ends with anol. So let's go and have a look at the different compounds. So the first one that you're going to have is methanol. So again, methanol is going to be C with an OH group bonded on the side. And then each carbon has got 4 bonds. So that's going to be methanol. The way that would be written is CH3 and then OH at the end. So again, it's the OH that marks it out as an alcohol. Move on to the next one. 2 carbons bonded to an OH at the end. And again, your bonds all the way around, and this is going to be ethanol because it's got 2 carbons. This will be written as C2H5OH, and we've used this before. Next, you have propanol. So propanol is slightly different. So with propanol, we've got to do 3 carbons. So we can go 1, 2, 3, and we can put the OH at the end, and then we can cover our carbons with hydrogens, and that gives us propanol. But propanol can also be drawn as this. If we have carbons like this, we can put the OH group here in the middle rather than at the end. So the OH group can move around. This is still propanol. So how do we distinguish between the two? Because although very similar, they are actually different molecules. They are different compounds. So this particular one here is actually called propan 1-ol, whereas this one here and the second one is called propan 2-ol. And the main reason for that is the number of carbon that it's on. This is on the first carbon, this is on the second carbon. So there is a difference between these. These are not the same. They are not the same compound. So these two things, although they have the same amount of carbons and hydrogens and oxygens, they have different structures. So they have the same molecular formula, but different structural formulas. Therefore, these are isomers. Okay, next we move on to bute. So there is 2 isomers. So the next one we're going to do is we're going to work on to bute, and bute works the same way. Again, 4 carbons. So we can have 1, 2, 3, 4 with an OH group at the end. So this particular substance is called butanol. We can then do another 4 carbons again, and we'll realize that we can move the OH group. So I can put the OH group here, and again surround by hydrogens. And this one is going to give me butan 2-ol, because the ol, or the OH group, is on the second carbon. Up here, this is butanol. It can also be called butan 1-ol. Right? On to the next one then. Is there another way of doing it? So some people go, well, maybe you can do butan 3-ol. The problem is, if you put an OH group here, and this is gone, well then this is just going to be the same compound again, just reversed, because you would be numbering from this side. You would have 1 and 2, so this would just be butan 2-ol. So there is no butan 3-ol. So before we move any further, let's just actually count up the number of carbons and hydrogens that we've got here. So in our propanol, we're going to have C3H7OH, and we C3H7OH in that one. When we move on to the 4 carbons, we look at butanol, or butan 1-ol. So this one here is C4H9OH. And this one here is also C4H9OH. When we move on to the next one, we can create another isomer by actually knocking off a carbon. So for example, if we do this, 1, 2, 3, and by knocking off a carbon we introduce a CH3 group, and then pop our alcohol group at the end. When you count up all the carbons, this one here is still C4H9OH. That is, there's 4 carbons, there's 9 hydrogens, and there's an OH group. But you can clearly see that this is a very different structure. So this one here, if we wanted to label this, we've got 3 carbons in the longest chain, so this is prop. It's got an alcohol group at the end, so it's propanol. And there's a methyl group, which makes it methylpropanol, and it's on the second carbon. So that is 2-methylpropanol. Now again, in this one here, you want to be maybe a little bit more specific. When you write propanol, that just means it's a prop with an alcohol group in it. You should be really stating where the alcohol group is. So this technically should be written as 2-methyl prop and 1-ol, because the ol group, the OH group, is on the first carbon. So this will be numbered from this side, 1, 2, 3. So you number from the side of your functional group, which is OH. There's another way we could draw this. We could actually move the OH group from the end and bring it into the middle. So we could go like this. This would give us a different structure again. However, when you count up all the carbons and the hydrogens, you still end up with C4H9OH. And this substance here, again, you can number from either side now because it's in the middle, is again going to be propan. There's 3 carbons, there's the longest chain. The OH group, the alcohol group, is on the second carbon, so it's propan-2-ol. You have a methyl, also on the second carbon, so this is methylpropanol. That's going to be 2-methylpropan-2-ol. Now they seem similar, but they are very different. So let's go back and see, when we're working with C4, 4 carbons, we have got 1, 2, 3, 4 isomers. So there's 4 isomers of these. And that's it. 4 isomers. That's when you go up to 4 carbons. At 3 carbons, there's only 2 isomers. Then 2 carbons and 1 carbons before that. The next section we're going to look at is what's called primary, secondary, and tertiary alcohols. I'll write the title down for this and a couple of diagrams in back in 1 second. Okay, so let's have a look at these primary, secondary, tertiary alcohols. So the shorthand for primary is 1 with a 0 at the top or a degree sign. Secondary then is 2 and tertiary is 3. So when you're looking at these, here's an example of the 3 types. So we'll start with the first one, and this is ethanol. And this is a primary alcohol. Now, what makes it a primary alcohol is how many carbons this carbon is bonded to. So this is the carbon that's bonded to the OH group. What you have to ask is that carbon, how many carbons is that bonded to? That is only bonded to 1 carbon. Therefore, it's a primary alcohol. When you look at the next example, the carbon that's bonded to the OH group, which there's the OH group, the carbon that's bonded to the OH group is bonded to 2 carbons. And this makes this a secondary alcohol. And then the final example is this long one here, where the carbon that's bonded to the OH group, which is the one in the middle, is bonded to 3 other carbons. And this is tertiary. For the next, one of the next sections that you're going to be studying, which is carboxylic acids and esters, these primary alcohols, secondary alcohols, and tertiary alcohols, especially primary and secondary, it's really important because primary alcohols will react in one way and secondary alcohols will react in another way. So there's your three main examples. So we're going to have a look at some uses of alcohol. So let's go through them. So the first one we're going to look at is methanol. So methanol, there's something to know about methanol is that it's toxic. It can kill you if you ingest it. And this is an additive. And what did they add it to it? They actually added to industrial alcohol. Now, industrial alcohol is basically ethanol. Ethanol is used in alcoholic drinks. And it's also used as a solvent in science work. But the problem is, ethanol is very expensive. There's huge taxes on it. And if people get their hands on ethanol, they can suffer from alcohol poisoning if they drink it. So what they do is they add a small little bit of methanol into the ethanol. By putting the methanol in the ethanol, it makes the ethanol undrinkable because it will poison you. And because of this, this is what's called a denaturing agent. And that makes the ethanol undrinkable. How are alcoholic drinks formed? Well, it's the fermentation of glucose. So if you take glucose, which is C6H12O6, the sugar, and you react that with yeast, you end up with ethanol, which is C2H5OH. And we've got two of those. And you also end up with carbon dioxide, CO2, two CO2s. So that's the fermentation. And that experiment is done in Lebensart biology. Those of you who are doing Lebensart biology will probably know that experiment, or you'll be doing it in 6th year.